So today we are going to see the next question, that is in the deep dive session, that is 1202, and we'll see that uh, the is approaches, right? So first let's read the question. The smallest string with the swaps. So if I'll talk about this statement, it is saying you are given a string s and an array of pair of indices with the in the string pairs, and pair at I is what, a and b. So if you and pair of a pair at the I, what we have two things given, a and b. So it indicates what, two indices it indicates, right? So a and b, each of them are indicates two indices. It's a combination two indices, right, of the string. Now what we can do, you can swap the characters at any pair of the indices in the given pairs any number of times, right? So it is saying you can swap the characters at any pair of indices in the given string. Okay, so we have to swap the character. What we will do, swap a character at any pair of indices, at any pair of indices in the given pairs. We can do that, right? Next it is saying we have to return the lexicographic smallest string, and that can be changed to after using the swap. Okay, so we can change that. Let's assume that we have example one in which we have given s is given what it is giving d, correct, and now we have d c a b. Okay, here. Okay, now it has given two things. Another thing is what, pairs, right? If we'll talk about pairs, it is 0 3 is given. Next it is given 1 and 2. Okay, like this, two thing is given. So if we'll talk about, this is a and this is b. Okay, so for when we are going to at this position, right, let's assume that we have 0 and 3. So I'll take 0 and 3. So we have to swap at 0 and 3, means s at 0 and s at what, 3. We will swap, right? Swap this. What we will get this now? Now our string is what? After swapping, this is what at index 0, and this is what, 0 1 2 and 3. So we will swap what, d and b, correct? So now it will become b, c, a, and b will be d. So this job is done. Now we'll go to 1 2. Now we'll go to 1 2. What we will do here, we'll take s at what, 1, and s at what, 2. So at 1, here what we have, 0 1 2 3. So 1 we have c, and this one is a, right? Now swap this one. Now this string will become like this, s equal to we are changing c and a, c with a, right? So b will become same, c will become now a, and a will become what, c, and d will remain same. So this is coming like this one, b a c d. So this is our smallest lexicographic string we have, that we have used after the swaps, right? So if we'll see the output, yeah, it's matching b a c d. Similarly, if we'll talk about another one, right, it is given as dcab is given. Now we had to add pair this and this is given, right? So each pair contains 0 a and b, right? So if we'll talk about the first one, right, we are taking this one. So add 0 and add 1, add 3. We will after swap, right, what we have, uh, we will swap d with a, and d with a, right? So we at index this one, we have to change this one as d will become b, and c and a will remain same, but d will be changed. Now after 0 and 2, now after this swap, right, we have to change another one, 0 and 2. So 0 we have what, this one, and this is what, at A is at 2 position, right? So we will change, this is 1. So what we will do, we have to change B and A. So now if we change this one, B will become A and A will become B. That is done, right? Now if we'll change with this one 0 and 1, 0 and 2, right? 0 and 2, 0 and 2. Okay, now we are using 0 and 2. So if we'll change this one, so it will become like this. So as you have seen here, we have first taken what? This one, right? This pair we have taken, and after this we are not taking this one, right? We are taking this one in the example. Here in the example you will see, right? So 0 and 2 we have taken, and so that it is changing this one. So this one is done, this one is done. Now we are using this one. Okay, so if we'll change swap at 1 and swap at 2, so it will look like what? A B C D, like this. Okay, so that's why it is saying uh, you can swap the character at any pair of indices in the given pairs. Okay, you will change, you can use any pair, right? Now if we'll talk about this one, right? Now have two value, we have what we have given this one and this one in the pair. So first in the example, if you see, it is swapping what? 0 and 1 using this one, right? So what we will get after swapping, we will get this one. You know how to swap this, right? Character. Next time it is coming to swap using this one, right? So it will swap and it will give you this one. But again it is not sorted, sorry, it is not showing smallest one, right? So what we can do, we will swap again. So after swapping, it will go to again this one, this position. Okay, at this position. So now it will come ABCD. Means if it will not be lexicographic smallest, what we'll do, we will iterate over as many time as, right? So three example you have seen, in which we will, what we have seen, we can, here we will say we have moved directly and we have find out the lexicographic smallest, right, string, and then we are done. Second example we have seen, in which what we are doing, we are using what? The given thing, right? But we will take any order of the pair. So first we have taken this or this one, second we have taken this one, and the last we have taken this one, right? So we can take any order at any time. Another we have taken what? We have gone through the order, this one and this one, but we are again repeating this loop, right? We are choosing again, right? So if we'll not get sorted here, smallest we are not getting, so we'll repeat this until we will find that. Okay, and in the constant, if you'll see that it is saying that we have only s is only contains in the lowercase English letter, so that we have to check, that we have to think. Length will this one and this one. Okay, so let's see how we'll do that. So if we'll talk about the what we have understand till now, we have string, right? And that is given in the lower case of English, and some pairs we have given in the form of A and B, right? And where A and B are indices in the string. So our goal is to find the lexicographically smallest string by swapping this at the indices A and B, correct? So there is no restriction of maximum number of steps, right? You can do as many as in this loop, right? You can do. So what we have to take care, the note, if I'll tell, the important point to note here is that if we have a pair like A, B and B, C, let's suppose. So then we can swap the character at indices what? A and C2. Okay. Although we don't have the pair AC. In this, if you'll see, we don't have what? AC we don't have. But we can do that. We can swap it. Although we don't have the pair A and C, we can still swap them by first swapping them with the character at index what, B, right? So at index B you can say, because we have here also, right? Now we can say that so because we can swap the character, we can swap the characters at these indices, right? So any number of times you can do, right? We can swap any number of times, and we can rearrange the character A, B, C, right? A, B, C character in any order, okay? Into any order, we can rearrange this one character. Let's suppose this can be, if we'll have, let's suppose, give me here, okay. Let's suppose this can be depicted as a graph problem, okay? So each indices in vertex and each pair is a edge between the vertices, okay? So an edge implies what, we can travel from one vertex to another, right? If this is v1, this is v2. So, or in other words, we can also say we can swap them as on here, right? We can swap either here or it will go to here. Let's suppose we have some value, right? We have some pairs and we will draw an edge between them. So if the pair of the vertices exist on the same path, they can be swapped by repeating swapping of each other in the vertices. Let's if I'll take this is the pair, and this pair is given like what, 0. We can draw in this one, right? Let's see, I'll take like this. We have 0, 3 pair. In the next position what we have, 2 and 5. Let's suppose another will take 7, 2. Next we can take 2, 3. Next we can take 5, 7. And the last one we can take 1, 4. Let's suppose these are given pairs we have, okay? So what we have understand till now, right? We have some pairs, right? And this is this pair, okay? So we can draw an edge between two vertices of each pair, and if the pair of the vertices exist on the same path, then they can be swapped by repeating swapping the other vertices in the pair. Let's if I'll talk about this, if we'll draw this one, this pair, so what will come first is 0, 3. So I'll connect 0 and 3. So 0 and 3 will look like this, right? Now what we have, 2 and 5. So I'll take 2 here and there is 5 we have, right? Now what we have, 7, 2 we have, right? 7, 2. So if I'll take the 7 here in between them, 2 and 5, right? So we can say that this is our 7, okay? And I will connect between this. Now what we have, 2, 3 we have. So we can connect 2 to 3. And then what we have, 2, 3 we have here 5, 7. So we will connect 5, 7. And now we have 1, 4, right? So I'll take 1 here and we'll take 4 here. We can connect. So this graph will look like this one if we'll take this pair, right? So no pair at 0, 7. If we'll talk about, there is no pair, right? There is no connection, right? There is no connection of 0, 7. So we'll say no pair we have for 0, 7, correct? But we can still swap the character at 0 to 7, got it? But we can swap 0 to 7. But we can, if we'll take, but can swap what character at what, 0 and 7, got it? Character at 0 and 7 we can swap, right? Because we have the linking, right? So if we want to swap what for this one, right? So first we will do what? We will do swapping between let me draw. Yeah, if we want to swap this one, right? So first we will swap like this, what? 2 and 2 and 7, right? So we will, after the swap, what will happen? This will look like what? We'll take 0, 3. Now 2 will become 7, suppose. This will become 2, this will become 5, and this will become what? 4, and 1 will remain same, correct? Because what we have swap, here we have swap 2 7, right? Now let me choose another color. I'll take this one. Okay, now suppose we will swap what? 3 and 7. Okay, these two. Okay, and these are connectors, sorry. So 3 and 7, if we'll swap this one, right? So it will become look like what? 0. Now it will connect it to what? 7, and this is connected with 3. It is connected with 2. It is connected with what? 5, and this is 4 and 1, right? This will look like this one. So if I'll go back here in the red color, okay. Now you can swap what? These two. We can swap these two, correct? 0 and 7, correct? This will be our approach. So we don't have pairs. I was talking about this one. We don't have pairs, right? But we can swap what? We can swap 0 and 7 character like this. So now this demonstrate how we can swap any pair of vertices that is present, right, in the same connected component. Thus we can rearrange the character in such a way that any character is at any index within the connected component, right? We can do that, right? And so to find the lexicographic smallest string, we need to sort the characters that correspond to these indices in the ascending order, and then we will place the ith character at the ith index, okay, whatever the index we have given. So therefore we can break the solution down into some problems. Let's suppose uh, we have this graph, we have built this graph using, let's suppose we have given pairs, right? So we'll find the connected component in the graph, and then we'll sort the characters in the each connected component in the ascending order, and we will build the smallest string. So the biggest challenge in solving the problem, we figure out that we, with infinite swap, we can say we can arrange all the characters that belongs to the same connected component in the sorted order. And with the hurdle behind us is our next challenge, right? What is that? How do we find out which indices belongs to the same connected component? So that we can use DFS, BFS, union find are each commonly used to find connected components, right? These are solution approach, right? So since the DFS and BFS solutions are quite similar in implementation, so we can only cover DFS or BFS, right? And then we can use union find. Okay, so I'll try to do with first DFS, and then we will go for DFS. And if you find we require the another process, right, either BFS or DFS, then we'll do that. Okay, so let's understand. First we will use what? DFS, depth first search, in which we will see that uh, intuition, right? So let's read this intuition. Okay, so we will build the adjacency list first. What we will do? We will build the adjacency list using this given pair. For each pair x y, we will add edge between a x to y and from y to x. And then we will iterate over the indices 0 to n minus 1, where n is the length of the string given, right? And for each index, what we will do, if it has not been visited yet, right? If it is not visited yet, right, then what we will do, we will perform a DFS or BFS. What we will do, right? We will do DFS, and then we will store the vertex at and the character at these indices in the list, right? Then we will store the vertices in the vertices and then character these indices in the list. Now what we will do, each list will represent a different component, okay? And then we will sort each list indices and each list of character, and then we will place the ith character ith index, and we will give what a smallest in string we will get, and we will return that. Okay, so let's go to the browser section of the lead code, right? And then we'll implement there. So make sure first we will make what adjacency list, right? And we will make the s between them, right? Then what we will do, we will iterate over the indices from 0 to n minus 1, that is our step 2. And then for each indices, right, if it is not visited, then we will perform DFS, right? DFS will do, and then we will store what in the vertices, and at each character we will do that, right? And finally in the fourth position, we will each list will represent a different component in the graph. So what we will do, we will sort this one, this graph, we will sort this graph, and then we will return that. Okay, so if I'll represent this one in the algorithm, right? So what we will do, we will iterate over the pair, right? We will iterate over the pairs and we'll create an adjacency list, right? In such a way, adjacency at source, right, contains all the adjacency vertices in the source, and then we will iterate over the indices from what 0 to size minus 1. For each indices vertex, we will do what DFS, right? We will perform DFS. If vertices is not visited, then we will perform DFS and we will store the vertices in the list, and we will say character at what s attribute index is the list of character, right? Then we will do sort the list indices and the characters, and we will iterate over the indices and character. So what we should do, we will place the ith character at the ith indices, and we'll say this is our smallest string, and finally we will return this, right? So what should we do? First we will iterate over the pair and we'll create the adjacency list. Now we will iterate over the given indices, right? And then we will store our we will do a DFS, and if this is not visited, then we will store in the list. And so now we have the we can do we have this list, so we will sort this, and after the sorting we will do iterate, we will do iteration over the indices and characters, right? So, and we will place the characters in the smallest string, right? And then we will return this. So let's see on the browser section of this program, right? And let's see here in the code browser. Okay, and we have implemented this one, right? So let's assume we have the number of vertices, right? And that vertices what we have given final static int n, right? And we have taken this long value, okay, into the integer, right? And we have created one visited, right? And in this we have created a visited, and this will contain all the visited one, right? And the will create the adjacency like this. Okay, so now we have created one separate method, that is DFS, and then we'll call this DFS into our this function. Okay, so let's understand this DFS, right? First we will understand this one. Okay, so in which we will pass what we have given, a string we have given, and pairs we have given, right, as per the question, right? And then what we will do, we will iterate over the given string, and we will initialize our what adjacency list, right? And after that what we should do, we will make our pair and we will store each pair, right? The first pair where we have we have source, and another is a destination. So we will, let's suppose this is undirected, so we will update our adjacency. For the source we have destination, and for the destination we have the source, right? Now adjacency matrix is adjacency list, you can say, it is updated, right? Now we will take a answer and we will return this one, right? So what we should do, we will iterate each character, right? And then each character is a vertex, we can say, and we'll return this answer in the finally, right? So what we will do here, right, in this loop, we'll go for all the vertices. We'll start vertices from 0 to length, and then we will do what, DFS if it is not covered in the DFS. So what we will check, if not visited these vertices, if this is not visited, then we will create in characters and indices, as I told you in the algorithm, right? So we will take to list, character list and indices list, right? And then we will take what, DFS. We will do DFS, in which we will pass the string, vertex and character list, and after doing the DFS, right, we will have our character indices is updated, all the values will have, right? So we should do sorting of this one, right? So we will do collections dot sort and we'll pass character list and indices list. So now this is done. So what we will have here in the final, we will store, and we will store the sorted characters and in the corresponding index, we can say. So we'll start with what, index is 0 to its character size, and then we will update our answer string that is in the character array, so that we will have the each index we will have, we'll get from the indices, and we'll store from the character dot get will do, and we will get our what answer. Finally we will return our answer in the form of string, because this is our character. So what we have not understand, that is our DFS, right? So what we have given in the DFS, we have given what, we are passing string vertices, characters and indices list, right? So at each character, at each character at a string, right, s dot char at what is that vertices, right, we will add into the character, and that vertices we will say the indices we will add as a vertices, right? So both character and indices we are maintaining in the two separate lists, and if this vertices visited, so this should be into the visited record, right? So if it is not visited, right, that's why we are coming here. So we'll update this one for the next time, if this is visited or not. Next what we will do, we will take reward adjust sorry, I'm sorry. Next we will do what, traverse the adjacency list, and so that we will do uh, we'll get all its children, right, that is adjacents, you can say neighbor also. So from the we will pass the vertex and we'll get all its adjacent, and so that if this is not visited, if this adjacent is not in the visited, means we don't have the record that we have visited or not. Then we will call again the DFS, we will iterate it again, okay, and recursively we will call this function DFS, and we'll pass a string adjacency, and adjacency is a vertices, right, and character list will pass, and indices list will pass, right? So it will actually this function will update your what, indices and character list, right? That's all I have. So thank you guys. If you have any doubt, please ping me in the comment box, okay? And please ping you can say complexity, and if not, then we will go with another approach, right? Union find will do, in which we will see this approach, right? So we'll see that complexity, you can say. So let me try this one. It's working fine. Okay, thank you guys, thank you so much. Please comment the complexity.